Okay, hey everyone. While you guys are watching this ed puzzle, there's going to be a couple questions that you're going to have to answer on the ed puzzle, okay? Again, I am grading you on completion, okay? But really, please try your best on these questions so I can see where we're at. Also, while you're watching the ed puzzle, I really want you guys to take out that worksheet, okay? Do you like green Skittles? And copy down the notes. So you're going to have to pause me at some point, okay? And just make sure you have all the notes copied down along with the ed puzzle questions answered. So the scenario is, in 2013, Skittles changed the flavor of green from lime to sour apples. Mr. Wilcox takes a small handful of 5 Skittles from a bin of 10,000 Skittles and gets all green. If 20% of the Skittles are green, what is the probability of this happening? So the first question I'm going to have you guys answer is this a binomial setting, and explain. All right, so tell me, does this satisfy all 4 conditions of bins? So let's look at this, okay? So we have B, I, and S. So remember, B is talking about success and failure, okay? So my success is picking all greens, and my failure is picking any other color. Okay, so far it's satisfied that. Independent, so is picking these 5 Skittles all green, is that independent? So is every time I pick a Skittle independent of the next? The answer is no, because it doesn't say that we're replacing that green Skittle. So after we pick the first one, or any kind of Skittle, we're not replacing it back into the bucket. So this is not satisfied. And since this is not satisfied, then we say it's not a binomial distribution or a binomial setting, okay? So this is no replacement. All right, so let's look at the next question. The next question says, find the probability. So now I know it's not a binomial setting, so I can't use binomial PDF or CDF, okay? So we got to think about, we're finding the probability that the first one that I pick is green, and then the second one I also pick is green. And remember, we're not placing that back into the whole bucket. So if I started out with 10,000, my next time I'm picking something and it's green, I have one less than 10,000, okay? So can you guys give that a try? Try to find the probability that picking all green. So the probability of all 5 green, all right? So something we needed to realize with this is you guys might have been stuck on, well, I don't know how many green are actually in the bin. If you remember, it said 20% of all my 10,000 is green. So 20% of that 10,000 is 2,000. So I know my first try, I have 2,000 out of 10,000 to get green. I pick a green, I don't replace it. So that means now I have one less in my bin, and I have one less green. And then it just keeps going one less, because I'm telling you I'm picking 5 green. And I'm multiplying these. Okay. And I get 0.000319. All right? Next question. Find the probability of getting 5 green Skittles if this was a binomial setting. So now you can use your binomial PDF because it is exactly 5 green. I'm going to review the formula. Okay, so I want to know what is it when these are exactly 5 green, and I'm saying, all right, let's pretend I ignore that independence rule. What would my what would my probability be? Can you guys find out what your probability would be? So we have 5C5. This is 5 number of trials. All of them are green. 0.20 to the 5th, and then 0.80. Okay? And we get 0.000320. Wait, look how close these are. But I thought it wasn't a binomial setting, so why am I getting so close? Okay, so we kind of answered this one. Why do you guys think I'm getting so close? Why don't you guys just take a guess? Take a guess on why you think my probability is so close. Okay, so this is almost the same. So the reason why my probability is almost so close, because I have such a small sample compared to my population. Okay, that's right now what we know. There's actually another reason that we're going to get into. Okay, but that 5 out of 10,000 is very small. So let's see. Now, Mr. Wilcox grabs a huge handful of 100 Skittles from the large bin of 10,000 Skittles. Let X equal the number of green Skittles in a handful of 100 Skittles. X can be considered a binomial random variable because the 10% condition is satisfied. Well, what is this 10% condition? Okay, so this 10% condition tells us that when we take a random sample and we don't have replacement, if the size n, which is our small n, that's our sample, if our sample size is less or 10% or less of the whole entire population, then we can just use binomial distribution. So that's why when I took in the last 2 questions, that's why these were so close, because that 5 Skittles is less than 10% of the total bin. Okay, another way, so if we look at this, if I do this, okay, added one. This 5 is much less than that 1,000, because 10% of 10,000 is 1,000. It's much less. So it satisfies this condition, so I can ignore independence. So let's look at another example. What is the probability of getting at most 11 green Skittles? So now I said we ignore the independence, so I can say that this is a binomial distribution. All right, so we can use that binomial, and we're going to use binomial CDF here because it's actually going to be in inequalities. All right, so can you find the probability of getting 11 green Skittles, or at most 11 green Skittles? So if I use my calculator, CDF, I'm going to say my trials is 100. My probability is 0.20, and my X is 11, and I got 0.0126. Now, this is the distribution as a histogram. So let's look. Can you guys tell me, what does this look like? What is the shape of this distribution? Okay, so the shape is normal. Okay, so why? Why is this normal? That's something we have to kind of think about, and we're going to answer it as we move on to these questions. So let's calculate the mean and the standard deviation. So we learned on Friday, or today if you're watching it tonight, how to calculate the mean and how to calculate the standard deviation of a binomial distribution. So we're going to use these 2 formulas. So can you first calculate the mean, please? So this is 100 times 0.20, which is 20. And now can you guys calculate the standard deviation? So the standard deviation is going to be 100 times 0.20 times 0.80, which is 4. All right, so let's see. If I use my normal CDF, will I get the same answer as when I use my binomial CDF? And I'm actually going to do a little review, okay, on z-scores, because you might have to use, you might not always be able to rely on your calculator. So your z-scores will help you find the probability. So remember, my z-score is my value minus my mean over my standard deviation. So can you guys find my z-scores? And we're using this mean and this standard deviation. So when I did 11 minus 20 over 4 equals negative 2.25. Once I get my z-scores, I'm going to open up my table A, and I'm going to look, okay, here's negative 2.2, and then I go all the way over to 5. So my probability of getting at most 11 is 0.0122. So from table A, I'm getting 0.0122. Again, this is very close to the probability that I found out here. I'm only off by a couple, and that's because of rounding errors. Okay? So what does that mean? Why is this binomial distribution a normal distribution? Why am I getting the same exact answers? Well, you can use normal approximation for binomial distribution. Suppose x has a binomial distribution with n trials and success probability of p. When n is large, the distribution of x is an approximate normal with the mean and standard deviation. Now we can only use this. We can only use the normal CDF, okay, and use a normal distribution when it satisfies this condition, okay? And we're going to do a problem together on it satisfying this condition where n times p is greater than 10 and n times 1 minus p is greater than 10. So here is your problem, okay? So it says, I just want to move it down so I can see it. Problem, in a survey of 506 teenagers, ages 14 to 19, subjects were asked a variety of questions about personal finance. One question asked teens if they had a debit card. Suppose that exactly 10% of teens ages 14 to 18 have debit cards. Let X equal the number of teens in the random sample size of 506 that have a debit card. So show the distribution X is approximately normal. So I want you guys to take a second. I want you to write out your bins, and I want you to answer the question, is this, not normal, I'm sorry, approximately binomial, is this a binomial distribution? So let's go over it. My success is debit cards, so if they have a debit card or not, and my failure is no debit card. So it does that one. Okay. Independence. So I don't see replacement here. So we need to see, will this 10% condition, and you guys will write 10% condition, does it satisfy? And it's safe to assume here that it does. Why can we assume that it does? Because we can assume that there are at least, okay, 5,060 teens. And where am I getting that number from? I'm getting this number because I'm going to do 506 times 10. Okay? So we can say that there is going to be probably more than that 5,000 teens. All right? And it's safe to assume this. My trial is n equals 506, and my probability of being successful is 0.10, okay, or the 10%, okay, and I got that from here. Now it says, check the conditions for using a normal approximation in this setting. So I need to check for two things. Is this true, and is this true? They both have to be true. So let's do that together. My n is my sample size, and my probability is 0.10. Is that greater than 10? Well, 50 times 506 times 0.10 is 50.6. That's greater than 10. We check it off. And we do the same thing over for my failures. My failures also need to be greater than 10. So this is 0.10, and this is going to be 0.90. And we get 455.4 greater than 10. So it's safe to assume that it's normal. Okay. And now we can use the normal distribution to estimate that the probability that 40 or fewer teens in the sample have a debit card. So I want you guys to answer this now. Use your z-scores, or you can use your calculator. And remember, if you guys don't have a calculator, what you can do is download it on your phone using Calculate 84. Okay. In order to do this, remember, we need to find out what my mean is, and we can use this. And we need to find out what my standard deviation is. Okay, so if you guys didn't do that, you wouldn't have been able to get your normal CDF. So my mean is going to be 506 times 0.10, which I did right here. It's 50.6. And my standard deviation is going to be 506 times 0.10 times 0.90, which gives us 6.75, and I am rounding, okay? So mine might be a little off if you guys didn't round. And then I'm going to use normal CDF. So my lower bound is 40 or fewer, so my lower bound has to be that negative 999. My upper bound needs to be 40. My mean is 50.6, and my standard deviation is 6.75, and I get 0.058, so about 5.8%. All right? So the things that we need to remember from today's lesson. First one, if we don't see replacement, we have to see if that 10% condition applies. If it does, then we can say that it's safe to say that this is a binomial distribution. Second, if we are able to pass both of these conditions, then we can also say it's safe to say that this is a normal approximation, and when we want to do the find the probability, we can use a normal distribution. These are your means and standard deviation, and this only works if I have a binomial distribution. If I don't have a binomial distribution, I can't find mean and standard deviation this way. So what you guys needed to do to get 100 on this activity, I need you to watch the Ed puzzle and try your hardest to answer those questions to the best of your abilities. And copy down all the notes on your Skittle worksheet. Then, also for homework, you need to do the check for understanding from today's lesson, or Friday's lesson, depending on when you're watching this. The check for understanding on the Skittles one, we're going to be maybe possibly working on that in class for the Do Now on Monday. Okay? And if you guys have any questions, please reach out via Remind. Okay? All right. Have a good weekend.